Hi guys, here with lesson 9 today on chemical change. So, chemical reactions are when some kind of new substance is produced, and that's with energy flowing from one part of the system to another. So, energy flowing, usually when we see that in the lab, it's in the form of heat. So, something could get really warm in the test tube when you touch it, or really cold. The other thing that you need to see to know that a chemical change has happened is a new substance being produced. The best example that we all know is vinegar and baking soda. So if you put those two together, you're going to make bubbles. And what are the bubbles actually showing? They're showing that you're making a new substance that's a gas. So that's a really common household reaction that we see. So some terms here, we have reactants and products. So reactants would be the things that you put together in your test tube, and the product would be what's formed after those go together. So in my example of vinegar and baking soda, those are called reactants, and then the bubbles or the gas that's produced is the product. Really important that we know what state we're working with. If I need to go into the lab and I need to grab copper 2 sulfate, it's really important that I know whether I'm grabbing solid or aqueous, because if I need aqueous, I need to dissolve it in water first for us to use it in the lab. So it's really important when you're writing your chemical formulas, like we've been practicing, that you're checking with the solubility table and you're putting the appropriate state behind everything. All of your elements, so if you just have, say, hydrogen, you're going to find the state of those elements on your data booklet. So in the top right-hand corner, sort of, or the right top page, you can see the color coding on the data table. It will tell you if something is solid, liquid, or gas based on what color the box is on the periodic table. So for example, there's only a couple boxes on the periodic table that are black because there's only a couple elements like mercury that are going to be liquid at room temperature. Most other boxes on the periodic table are just white, meaning they're solids. And then we have some things that are gaseous or gases at room temperature, like some of these nonmetals, hydrogen gas, nitrogen gas, oxygen gas, etc. Now, if you've got an ionic compound, we do try hard to make sure that you can find them all on your solubility table, but if you can't, it's okay just to default to calling them solids. That's what we were doing when we didn't know about the solubility table. So if you can't find it, just write solid when it's ionic. Any molecular compounds, that's a lesson that we skipped. Those are ones that we would call like carbon tetrahydride. We would put those prefixes in front, like mono, di, tri, and those ones usually have special names anyway. So that's why we skipped over them during this emergency remote learning that we're doing. Those ones can usually be found in your data booklet. If you look around, there's a couple pages that have lists of them, and they usually have special names. Like this one, CH4, it's natural gas. It's what comes into our house if you have a gas stove or a gas barbecue, and it's called methane. Here's those energy changes I was talking about. So exothermic and endothermic. So we saw these prefixes in our biology lab when we were talking about exocytosis and endocytosis. So exo meaning exiting. So energy is exiting or being released, usually in the form of heat, but you can also see light or electricity. We usually don't see this in grade 10. Endothermic, entering, so absorbing energy. This is what happens when something gets cold. So the heat energy is actually absorbed and something loses heat. So this is the reaction that happens in those ice packs that you kind of crush. You crush the contents and a chemical reaction happens that's endothermic and they get really cold. That's exactly what's happening there. Combustion is another energy change. This is what powers things like our vehicles. We're going to study combustion reactions later on in much more detail. Photosynthesis and cellular respiration both happen in plants. Photosynthesis is an example of an endothermic reaction, and cellular respiration is exothermic. You study these two reactions in detail in Bio 20 next year. Now, this looks to me like it is crazy important in the notes, the characteristics of a chemical reaction. So if I show you some kind of lab, you have to be seeing a new substance being produced in order to know a chemical reaction has taken place. So the difference here when you've got a chemical reaction and you just have a phase change. Phases, remember, water is probably the easiest example. If I have a piece of ice and I let it melt, that's simply a change in state. It's gone from solid to liquid. There's no chemical reaction happening whatsoever because the H2O that I had in the beginning is still H2O. There's no new substance. But when I see something like bubbles produced when I put vinegar and baking soda together, that's producing a new substance, a gas that's completely a different rearrangement of the original atoms that were in that substance. You might see what we call a precipitate. So I'll show you this in a lab video, but a precipitate is when something forms that's solid. So if I'm putting two compounds in my test tube and all of a sudden I get some solid chunks in it, that sounds really disgusting, but sometimes they can be really cool looking in different colors. That's what we call a precipitate. How do you know something's going to be a precipitate? Well, if you look on your solubility table and you see that those two elements will form a solid, that means that in your test tube, they become solid or a precipitate. You might have a change in temperature for chemical reactions, but not always. You might have change in state. So like we said, if you mix two liquids together, you might get a precipitate, which is a solid, or you might mix two liquids and get a gas that has bubbles being produced. But what's always true is that mass is conserved. So chemistry and physics both have big laws that we're going to study. In chemistry, it's called the law of conservation of mass. The way that I show you this usually is we go into the lab and we do the vinegar and the baking soda, but we don't just do like an old school volcano like you could do at home if you're looking for a science activity to do with your younger siblings or just to have fun. But we mix it so that we can contain all of the gas. So what I would do is I would take vinegar in an Erlenmeyer flask, the triangular one, and I would put some baking soda in a balloon. I'm going to hook the balloon on top and flip the balloon up so the baking soda falls down. The chemical reaction will happen, and since we know the bubbles are producing gas, the balloon is going to blow up. I do all of this for you in the chem lab on a scale or a balance so we can see what the mass is the entire time. And what you should notice if we're able to capture all of that gas is that the mass of the Erlenmeyer flask, the balloon, the vinegar, and the baking soda before, so the reactants before, is exactly the same as all of the gas that's trapped and the Erlenmeyer flask and the balloon that you get after. So this is just saying that if you start with a certain number of atoms, you're going to end with the same number of atoms. They may have changed state, they may have rearranged to produce new substances, but the number is going to be the same. So for instance, if I have 5 hydrogens at the beginning of a reaction and all of this chemical reaction takes place and they rearrange to form new substances, I should still have 5 hydrogen atoms at the end. That's what the law of conservation of mass says. There's an example here that says we're burning magnesium metal. So 23 grams of magnesium metal is burned in pure oxygen. The product is weighed and 39 grams of magnesium oxide is collected. Where did the extra 16 grams come from? So in this example, we've weighed the magnesium, but we have not weighed the pure oxygen. This is one of the reactants. You need this oxygen in order for magnesium and oxygen to have a chemical reaction and combine to make magnesium oxide. So if this is one of the reactants, we need to know what the mass of this is in order for this reaction to maintain the law of conservation of mass. So usually if we don't see the law of conservation of mass right away, it's because something was a gas, and gases are really hard to measure if we don't capture them, like I did in the balloon example. So if I knew magnesium was 23 grams and the only product I get, magnesium oxide, is 39, I went 39 minus 23 is 16 grams of oxygen gas that I was working with. I just didn't have a way to measure it when it was in the gaseous form. So this here is kind of a precursor to what the next lesson is. In the next lesson, I'm going to teach you how to write these equations in chemistry, where we have our reactants on one side and our products on the other. And what this means is that a chemical reaction has taken place. So a new substance was formed from the original reactants. Now, when I last did this, there are no practice booklet questions for lesson 9, but what you can do is go back and finish all your practice booklet questions that you still aren't done. If this means you need to set up a video chat with me so I can help you with the ones that you're stuck on, I would love to do that. Remember that we skipped lesson 8 or lesson 7, I believe, on molecular compounds. So you don't know how to name molecular compounds, but if you are interested, because you're going into Chem 20 next year, you're welcome to Google that and learn how to do that as well. I know lots of Science 9 teachers cover it anyways. Now, the second task that was due when I taught this last year was to complete the lab prep, because we were going to do a lab on this after. You won't have to do that, but like I said, I will make a video of me doing the lab so you can see exactly what you would have done in class anyways. Maybe even light some stuff on fire, because I'm super sad that I won't be able to light all of you on fire like we talked about. So there you have it. Give me a call or an email if you need help. I really would love to help you on video chat. That's what I'm missing the most in all of this. The classroom is empty and I miss my students. So please let me know if you need help with this lesson or any other lessons. I would love to give you a hand.